next we're going to talk about components and circuits. We'll cover 47 questions, and there's 4 groups, so 4 of these will be on the test. We'll talk about resistors, capacitors, inductors, batteries, diodes, transistors, schematic diagrams, resonant or tuned circuits, and some other miscellaneous components like transformers, relays, fuses, etc. So first we'll talk about resistors, and we know that they oppose the flow of current for all forms of current. The picture on the right of typical modern day resistors without showing these little surface mounts, which would be hard to see, especially if you try to actually work with some. I've been able to do it, but with about a 10 power magnifier on my head. We specify them in ohms. They come in fixed or standard values depending on the percentage of accuracy. Used to be 20%, 10, 5, and 1, and then you can get some even more precision than that, but they're rare. I don't see 20% much anymore. Those used to be the old carbon core resistors. Most of the newer ones are going to be 10 or 5. There's also a variable resistor. Sometimes we call it a potentiometer. It has 3 terminals instead of 2, where one is a wiper that moves along the resistance path, so it can vary the amount of resistance between one point and the wiper. And we use that when we're using all 3 leads. We typically call that a potentiometer because it's using a voltage divider, basically. If it's tied to one end, it's only varying the total amount of resistance. We use them in audio as a volume control. We use them in power supplies as a voltage control for a voltage regulator.
So there's what? 2 general flavors, linear and log linear or audio taper?
On the potentiometers, right, they're linear, and audio, I guess there's a log version of audio also.
I think the log and the audio may be the same thing.
Yeah. But that's not on the exam. It's just good to know. Okay. What electrical component opposes the flow of current in a DC circuit?
R.
B.
Very good. What type of component is often used as an adjustable volume control?
C.
C.
What electrical parameter is controlled by a potentiometer?
R.
B.
Okay, capacitors. A capacitor is 2 conductive surfaces separated by some form of insulator, which we call a dielectric. The amount of surface area and the separation determines the amount of capacitance. When we apply a voltage, a DC voltage, it charges the capacitor by making one plate positive, meaning it has atoms that are missing electrons or holes, and the other plate would be negative, means there's an excess of electrons. And it creates an electric field between those conductive surfaces or plates. That electric field can store energy. And the ability to store energy in that field is called capacitance. And we measure capacitance in farads, which I probably should have capitalized because it's another person, Michael Faraday. I think he was maybe American. Not sure.
I think he made it European because
Yeah.
he was part of the
Probably.
Royal Society.
On the left is a little thing showing the field and the alignment of the charges in a capacitor made with two plates, where we have a positive charge on one and negative on the other. And that charge is equivalent to the amount of energy stored. Now, I did a little circuit with the resistor and capacitor, and it shows down there the input voltage, which is just a square wave, which goes up to 1 volt. And you see that the voltage across the capacitor, which is the yellow or gold line, slowly charges up to the input value. Okay, so it starts off when you apply a voltage to a capacitor that's discharged, it looks like 0 ohms initially. And then as it's fully charged, it will look like an open circuit or infinite ohms. Likewise, when we take the voltage away, it starts to discharge back through the resistor in this particular circuit. And the rate at that decay is called time constant, which we won't go into for the technician. But the values of R and C determine how fast that charges and discharges. But the basic thing to remember is it stores energy in the electric field, and it charges up slowly depending on the circuit. What type of electrical component consists of conductive surfaces separated by an insulator?
B.
Both pits oscillating.
Well, it's involved in coal pits. What electrical component stores energy in an electric field?
B.
What describes the ability to store energy in an electric field? What is the unit of capacitance?
A.
Okay, inductors. We make inductors from a coil of wire, one or more turns. Actually, just a straight wire will have a little bit of inductance. As you coil it up, the magnetic fields tend to combine within the center. That magnetic field is caused by current passing through that conductor, and it stores energy in the magnetic field, similar to the way the capacitor stores energy in a electrostatic or electric field. And that ability is called inductance, to store energy in the magnetic field. And we measure that in henries, named after, it wasn't John Henry. Little diagram showing the magnetic lines of force and how they get concentrated in the center when you coil the wire up. And the more turns, the more that electric field is concentrated in the middle, and of course the higher the inductance. Similar to a capacitor, where the area of the conductors and the distance determines the amount of capacitance. In the inductance, it's going to be the number of turns and the diameter of the coils to determine how much inductance and how much the energy is stored in the magnetic field. Here's a similar circuit with an inductor and sort of a capacitor and how it charges up. And you notice on the inductor, it looks like have extremely high resistance initially. So we see the full, in this case, 10 volts across it. And as that magnetic field charges up, the voltage will decrease down to zero. So it will have no current flow initially. And once it's charged up, it will have the maximum current flow depending on that resistor in the circuit. Because if it was a perfect inductor, it would have no resistance. So it would look like 0 ohms at a certain point in time. When you take the voltage away, I have that magnetic field in there that starts to discharge, and that actually causes a reverse polarity voltage as it discharges back, because you're putting that energy back into the circuit. If you have ever dealt with things like relays, where you apply a voltage to it, or actually any kind of inductive thing where you've got a switch and you're applying a voltage and taking it away, as that magnetic field collapses, it generates extremely high opposing voltages, which will actually cause sparks to jump over the contacts, which is why in most relays on their solenoids, you put a clamping diode in the opposite direction, so it shorts that voltage out and discharges the field. What electrical component is typically constructed as a coil of wire?
No.
B.
Delta. What type of electrical component stores energy in a magnetic field?
C.
What describes the ability to store energy in a magnetic field?
Inductance.
D.
What's the unit of inductance?
C.
Okay, batteries. We have two types. We deal with rechargeable and non-rechargeable. Flashlight batteries are a common example of a non-rechargeable battery, even though they make rechargeable ones, but the standard carbon zinc battery can't be charged. This is a chemical reaction that goes on that's not reversible. And it's showing a little cutaway diagram of what's inside one of them. As a kid, we used to take them apart and get the carbon rod out of the middle. And then you could make a razor blade radio with that, winding a coil around it and using a safety pin and a razor blade. On the right is an example of a lithium battery. I think that's a lithium ion, but there's so many variations of lithium nowadays. But basically it has an electrolyte in it, and it uses some lithium material as one of the elements. And then I think in this one, the one collector is made out of copper and aluminum on the other side, but essentially that's just a rechargeable battery. And the ones that we normally deal with on rechargeables are lead acid, your car battery, or In some cases, you may use it for emergency power to power up a base station and recharge it with solar cells. Nickel cadmium, which isn't as popular today, but they're still around. Lithium ions. Most of your handheld radios are going to have some form of lithium rechargeable battery in them. Nickel metal hydride is another one of the older ones. The non-rechargeables are going to be your carbon zinc, your alkaline and mercury. Most of those are like the button cells that you see for watches and various small things. So which of the following battery chemistries is not rechargeable?
Zinc,
B,
Which of the following battery chemistries is rechargeable?
D,
Okay, diodes. It's your most basic semiconductor component. It's composed of two electrodes, an anode and a cathode. And we mark the cathode normally with a stripe, at least for the smaller diodes. As far as exams concerned, it's a stripe on the cathode. When they're forward biased, which means we have a positive current or positive voltage on the anode, they will conduct current from the anode to the cathode. When they're reverse biased, in other words, the opposite polarity, they will not conduct current unless you apply enough voltage to actually burn it up, and then it sort of becomes maybe a resistor, but it's no longer a diode. When you're passing current, it has a forward voltage drop, and that's dependent upon the type of material at the p-n junction. If it's a germanium diode, which aren't used as much anymore, but they're approximately 0.3 volts forward voltage drop. In other words, you have to get up to 0.3 volts before it will conduct. If it's made of silicon, it's approximately 0.7 volts before it conducts. And then we have a special, well, there's lots of variations of diodes, but the one on the exam, the other one is an LED or light emitting diode. When it is forward biased, it will emit visible light. That is, once you exceed its forward voltage drop. And because the materials are a little bit different for light emitting diodes, their forward voltage drops will be different. Not an exam question, but in some cases they're up maybe over a volt or more, depending on the type of material, and that determines the color. They're used as indicators in digital readouts.
We don't talk anymore about LCDs, kind of old technology.
General or extra,
Hmm.
not technician. Okay, the one on the left is showing the conventional current flow and electron flow or charge flow, and how it happens in that piece of semiconductor material, where when an atom loses its outer valence electron, it's called a hole. So there's a space there for an electron to jump into. So that's where the free electrons go. And while they're free and not attached to an atom, then it's a negative charge or a negative ion. When you've got an atom with a hole, it's a positive ion because it has a positive charge, because it has one more proton than it has electrons. Over on the right, showing the p-n junction for a diode, where there's a type of P-type material, and N-type material fused together. And at that junction called the depletion region is where this magic stuff happens with the biasing and the conduction. It'll go from P to N, but not N to P. The symbol it's used to represent it is next, which is that filled in triangle with a stripe. And that is the cathode, which is what's represented on most diodes. It will have a stripe on one end, indicating that's the cathode or negative end. A little bit about P and N material. You take a piece of silicon, which is a crystal, which is normally a non-conductor, and they do different processes to embed impurities. So the major one is a boron impurity that they put and make a P-type material. And if you can look at the little crystal lattice there, you see that it creates a hole, which gives that material a positive charge because it's got extra holes because of the fact that the outer electrons are different. And when you grow the boron in the crystal lattice, it causes some electrons to be shared and you wind up with an empty spot, lots of empty spots. For N-type, they normally use phosphorus to do the same kind of thing, except you wind up with excess electrons, so it makes it negative charge. Now, they also use some other materials, but boron and phosphorus are the most common. Sometimes they use antimony, arsenic, other things that are in that funny section of the periodic table to do different things. But basically, they make one piece of silicon positively charged with holes in it, and the other one with extra electrons in it. Here I just did a simulation, and they have a perfect diode in the simulator, which is what the gold line is. And you see that at zero, anything above 0 volts, it conducts. The slope of that line is the resistance value that's in series with it. The blue line represents a silicon typical semiconductor. I think it was the 1N4148. And because of the curve, it's actually hard to say where they measure that because it could be anywhere from 0.6 to probably 0.7. But on the exam, they call it 0.7. I think when you get into the general or extra, they've gone back to 0.6. It's somewhere in that range. And you can also see that the slope of the blue line is slightly less than the gold line because that diode has some internal resistance. Okay, what electric component allows current to flow in only one direction?
I'll say
See.
silicon.
What are the names for the electrodes in a diode?
C.
How is the cathode lead of a semiconductor diode often marked on the package? Did I hear a baker?
Mhm.
I guess it's Bravo, isn't it?
Probably.
It's Bravo now.
You're talking aims of nuclear tests, yeah, the alpha maker.
Which is true about forward voltage drop in a diode? Tricky one.
Well, A is true.
Yeah.
We have any votes for alpha?
I'll go for alpha.
See, they don't require you to know that it's 0.3 or 0.6 or 7, just that it's not the same. What causes a light emitting diode, an LED, to emit light?
Forward current. Okay.
Any alphas out there?
Yeah.
Which of the following is commonly used as a visual indicator?
A,
You need the Nixie tool.
Yeah. That's what.
Okay. Transistors. It's another semiconductor component. This time we've added a third piece of material. So we have either a P, an N, and a P, or an N, a P, and an N. There's sort of two flavors. There's the bipolar, which were the first, sort of the first ones that were practical. I think they had a theory about the field effect, but they couldn't make it work initially. A bipolar junction transistor uses current on the middle or the base element to control current flow between the other two, in this case, the collector and emitter. In a field effect transistor, which has source, gate, and drain, the gate is the controlling element, and it's controlled by voltage because it uses an electrostatic field to control the amount of current that flows between the other two terminals. It turns out that most field effect transistors are symmetrical, so you can switch it around and use the drain as the source and vice versa. It doesn't make any real difference. Just an aside, not on the test. Can be used as a switch, either one of them, where you can have it conduct current as a very, very low resistance or appear as a very, very high resistance. Looks just like a switch. Can also be used as an amplifier where you can vary the output current or the current through it proportional to the input signal, which is a current or a voltage, depending on whether it's a bipolar or a field effect. And that ability is called gain in order to amplify an input signal. So you can typically have a gain up to, I don't know, maybe 100 for simple amplifier circuits. And the gain is the ratio of the output to the input. So if it's power gain, it's output power to input power. If it's voltage gain, it's output voltage versus input. Likewise for current. That's one of the things that we tend to measure in dB. Okay, for a bipolar, like I said, the current input on the base is what controls the current output. And if you look at the construction, we have our diode, which is that PN junction from base to emitter. And it works, it's a diode. It has the same forward voltage drop. If it's a silicon transistor, it's going to be 0.6 or 0.7 volts before it starts to conduct. When you have current flow from the base to emitter, it allows proportional current to flow between the collector and emitter. I'm not going to try to explain how that works because I don't totally understand it. But, it gets into some of that quantum stuff. there are three electrodes called emitter, base, and collector. The schematic is there on the right. You see a little arrow on the emitter lead. And if it's an NPN resistor, which we're showing, that arrow is pointing towards the emitter. If it was a PNP, then the arrow would be in the opposite direction. It would still be on the emitter, but going into the substrate. Like I said, there's two types, a PNP and an NPN. NPN are the most commonly used, but sometimes you need a PNP because of the voltages you're dealing with. And they're just made from the same two types of material, and whether or not it's a PNP or an NPN layer. The field effect uses a voltage to control the output current, and that creates an electric field. And as you can see in the little diagram on the right, the field is between the gate and the body of it. And that controls the amount of current that can flow through that NPN junction that you see between source and drain, or drain and source. There's also two types, a P channel and an N channel. The symbols are down there on the bottom, and the arrow goes in or out depending on whether it's an NPN or a PNP. Like I said, they're gate, drain, and source. The gate is the controlling element. So they function just like the bipolar, except they use voltage on the controlling element to control it, as opposed to current through the controlling element.
Now, that's what's basically placed as the main diode for the front end on receivers.
Could be, yeah. Well, I mean, it is a diode. I mean, even there, you can get a diode effect. In fact, with the capacitance, I've seen them used as variable capacitors, just using the gate and source.
Oh,
Like a reverse diode, you can use it as a varactor. It appears as a capacitor, variable, voltage variable. Okay, which of these components can be used as an electronic switch?
yeah.
C.
You take C? All right, C's a winner. What's the term that describes a device's ability to amplify a signal?
Okay.
Which of the following can provide power gain?
B.
Yeah. Now, the reason they worded it that way and said power gain, and they threw in transformer,
That's voltage.
because the transformer can't provide power gain, but it can provide voltage or current gain. Which of the following components can consist of three regions of semiconductor material?
B.
Well, it doesn't have semiconductor material in a triode, but it works just like a FET. What are the names of the electrodes of a bipolar junction transistor?
B.
What does the abbreviation FET stand for?
Yeah.
D.
mean, it's not a frequency emission transmitter.
Sounds good.
What type of transistor has a gate, drain, and source?
Wow.
Bravo. Schematics. Okay, they're used to describe how a circuit works, how things are interconnected. It makes it easy to reproduce the circuit. They show the components. They show the interconnections. They tend to use standard symbols depending on what country you're in, which show the type of the component. Sometimes, and usually the value of the component. Sometimes it may have part numbers for manufacturing purposes. Here's a typical little schematic. You see a title block. Usually they have that, indicates when it was drawn, what the item is. They may have a little parts list or something attached. It shows all the various pieces, how they're interconnected together. I think that happened to be an Arduino of some sort. What is the name of an electrical wiring diagram that uses standard component symbols?
Yeah.
C.
Which of the following is accurately represented in electrical schematics?
C.
Yeah.
All right. Okay. Now, these are coming up are actual diagrams that will be on the exam. So they ask questions about them. So in this picture, number one is a resistor. That's the squiggly representation of a resistor. Number two is a transistor. In this case, it's a bipolar junction transistor. Number three is a lamp, not an LED, but an actual incandescent lamp like a pilot light,
Doesn't have little lightning bolts, so.
which you hardly see anymore, but yeah, they're still around, huh?
I was expecting an inductor in the lamp, but there's no inductor in there.
Yeah, there is. There's half a loop.
Half of it, okay.
And number four is a battery. Number five is one of the symbols for ground. Sometimes it's a triangle pointing down. So what is component one?
R.
Resistor. What is component two?
Well,
B.
What is the function of component two?
yeah.
Control flow.
Right. Because in this circuit, that signal coming in through resistor one is going to turn that transistor on and light the light. What is component three?
C.
Yeah.
What is component four?
D.
Oh.
Okay. Another one. Here we show an AC power plug as number one, a fuse as number two. Sometimes the fuse will have a little sine wave in it showing the element. Number three is a single pole, single throw switch. And notice it just has two terminals and a lever or contact that moves, it either connects it or disconnects it. Number 4 is a transformer. Number 5 is your diode. Number 6 is one of the representations for a capacitor. In some cases, whether it's an electrolytic or something, the symbol will vary slightly, but it will always be 2 plates separated. Number 7 is another resistor. This shows that you can rotate them. Number 8 is our LED, which is a diode with a couple arrows showing the light being emitted. Number 9 is our variable resistor. And in that case, whether it's tied to one end, it's actually just a variable resistor, not a potentiometer. And number 10 is a Zener diode, which you notice the little on the cathode, sort of a Z shape. And you notice it looks like it's backwards. That actually is. And it's uses what's called the Zener effect, where if you reverse bias the diode, and they make them special, it will conduct in the reverse direction at a particular voltage. So you can use it as a rudimentary voltage regulator. Okay, what type of switch is represented by component 3?
A.
Yeah.
What is component 4?
Duh.
D.
Okay. Diodes can also be used as rectifiers because they conduct in one direction. So we can convert alternating current to pulsing or pulsating direct current. And when they're doing that, we call it rectification, and we call them rectifiers. So in this little circuit, just a half wave rectifier. So we have 100, doesn't show there. Say it's 120 volts coming in through the switch to the transformer, and we get some higher or lower voltage coming out of it. And you notice in the plot, the gold line is the output or the secondary, and you see it follows the positive side of the input waveform, but it does not conduct on the negative. So you get these DC pulses, and the amplitude of that's going to be dependent on the turns ratio of that transformer. In this case, it's a step-up transformer because we're getting a higher voltage out than we put in. This kind of shows how a typical transformer of the old style is constructed, where you have 2 windings. You can have more than 2. A lot of times they'll have, especially in the old 2-type radios, they would have 3, 4 windings on them, one for the filaments and one for plate voltage and one for screens to generate different supply voltages. Most of the transformers in modern electronics are going to be done on a toroid, which is a piece of ferrite like a donut, but it works the same way. It kind of constricts the magnetic flux lines within that permeable material, and it's called mutual inductance. So the current going through one winding will induce a current or voltage through the other winding due to the sharing the magnetic field. If it's a step-up transformer, it means that we have more turns on the secondary than we do on the primary, so we'll get a higher voltage out of it, but we'll also get lower current because it only transforms, there's no gain. So the power will be the same, assuming you had no losses in the transformer. In the real world, there'll be some loss in the core, so you won't get all of the power out the other side. If it's a step down, you're going to get a lower voltage out, get a higher current capability out, higher current than on the primary. If it's an isolation transformer, it means it's 1-to-1. And that's used a lot of times just to isolate ground.
Also means you have like 3 dB and lost a little bit more.
I'm not sure what the loss is. It depends on the material and things, how many windings and resist,
So
the wire itself has got resistance, so that's part of the loss.
that's actually how they get rid of the noise a lot of times, just dropping the power. The noise is a smaller
Yeah.
portion.
A lot of the audio stuff, commercial uses 600 ohm, 1-to-1 transformers and then when they get to a final speaker, it goes 600 down to 8 or 16 or whatever. Okay, what component changes 120 volt AC power to a lower AC voltage for other uses?
Wow.
B,
Right, a transformer, it transforms. Which of the following devices or circuits changes an alternating current into a varying direct current signal?
B,
What is component 6?
B,
Only one faster. But that's
What is component 8?
very shiny, yeah. Yeah.
LED.
You don't know.
Yep.
But yeah, one black.
What is component 9?
C, hey, Robert, quick question on component 9. I see a connection going back. Is that a feedback loop back to the resistor?
You mean from the right side to the middle?
Yeah,
That's how it becomes a variable resistor. There's mechanically, there will be some sort of a wiper that slides along the resistive material. And that's what's connected to that third terminal. So
Okay.
as you move it from one end to the other, okay, it shorts out part of the resistor and allows the other. So it allows you to go from 0 ohms up to whatever the maximum value of that resistor is.
got it.
The component 6, the capacitor, what is the curved line telling us versus, 2 parallel lines?
I don't remember. But there's a reason why they do a curved one.
Yeah.
For electrolytics, it will usually be a straight line with little feet sticking up to indicate the negative side of an electrolytic. I don't remember what the curved line means, but as far as the exam, it's a capacitor, one of many types.
You're gonna be up tonight thinking.
I'll have to look that up. Did I explain number 9?
Yeah, that's good.
Yes.
Okay.
Yeah, it's like a dimmer switching.
Okay. There's 3 of these circuits that may be on the exam. You're probably going to get one of them. In this one, number 2 is a variable capacitor. This time it has straight lines indicating the plates. and the arrow means that they move relative to one another and mesh. Number 3 is a variable inductor. Now, that can be similar to the variable resistor, where there's some sort of wiper that moves along the coil, or it could be physical taps where you actually move it, or it could be, of course, in this case, they're not showing a core. Most of the variable inductors I'm familiar with had a movable ferrite core in them, and you could screw it in and out, and that would affect the amount of inductance. And in some cases, they actually used a brass core because it would, for small values in inductance. And number 4 is an antenna. So what is component 3?
Indeed.
What is component 4?
Okay.
Byron's favorite. Is that an end-fed?
Gotta be, if it's my favorite.
Okay. Resonant or tuned circuits. They are composed of inductors and capacitors, either in series or in parallel. Will usually be called an LC circuit. And I showed 2 examples of a series and a parallel down below. If it's a series tuned circuit, it means that it will have very low impedance or resistance at the resonant frequency. If everything was perfect, it would have 0 impedance or resistance at resonant frequency. If it's a parallel circuit shown in B, it's going to look like a very high impedance at the resonant frequency. In that particular circuit, it would look like when it's resonant, it would look like it's not even there. You just have the resistor. So the resistance of that circuit, it would just be R at resonance. The little animation is showing how it resonates, and what we're doing is taking the electric field charge and the capacitor, that energy, okay, and we store it up until it's full, okay, and it's no longer passing any current, and then it collapses and charges up the inductor and creates a magnetic field and stores that same amount of energy in the inductor up to the point where it stops storing, and then that tends to collapse, and it just oscillates back and forth. When that's happening, you get the effect of 0 impedance or maximum impedance, depending on whether it's series or parallel. Which of the following is a resonant or tuned circuit?
Okay.
Inductor or and capacitor, you have to have them both in series or parallel. Which of the following is combined with an inductor to make a resonant circuit?
D.
All right.
See.
Okay, other components. Switches are used to open and close circuits. We already saw a single pole, single throw switch. They can switch an input or output between two or more circuits. If it's a single pole double throw, or SPDT, which is shown in the diagram below, it connects a single circuit, which is the battery, between two other circuits, either the light bulb or the LED, depending on its position. So what is the function of a single pole double throw switch?
C.
Yeah, single circuit switch between one of two other circuits. Okay, a relay. It's an electrically controlled switch. It's kind of like a mechanical transistor. Okay, and I can either turn it on or turn it off by applying a current through the winding. And it causes the switch to move between one contact and the other. They can have multiple contacts, not just a single. It can be a single pole, single throw, or single pole double throw, or double pole double throw, lots of combinations. The voltage on the input, which causes current to flow through the inductor or coil part of it, will cause the relay, causes a magnetic field, which will attract the switch element, which is some metal, ferrous material that's moved by the magnetic field and causes a switch from one contact to the other. I don't know why they use, in this picture, I got the funny symbol for the diode in black, but okay. What is a relay?
Okay.
Okay, meters. They're used to display quantities as a numeric value. It can be an analog meter or a digital meter. In the analog meter, it's a little coil in there which is between some magnets, and it causes the little needle to move from one side to the other, proportional to the voltage or the current going through the meter. If it's a digital one, there's some electronics in there that converts to the digital display, which could be anything from LED numeric displays to arrays of LEDs to liquid crystal displays to Nixie tubes. There's tons of, there's gas discharge type that glow orange. Haven't seen those in a long time, but those were cool. They're normally used to display output voltage of a power supply or the power of a transmitter. Just tons of other uses. I mean, it might just be on a clock display for time. It could be on a weather display for temperature. Anything you want to display. Which of the following displays an electrical quantity as a numeric value?
C.
Integrated circuits. It's a usually silicon substrate that has other semiconductors and other components, can be resistors, inductors, capacitors, combined on it. That's why it's called an integrated circuit. Usually, like I said, it's silicon. If it's like a microprocessor, it will have millions of transistors in addition to lots of little capacitors and resistors on it. They can also be both analog or digital. In the case of analog integrated circuits, one of the most common is a voltage regulator, which you use in power supplies, whether it's a linear power supply or a switching power supply to control the output voltage. In the digital, it can be not only microprocessors, but any type of digital circuits. Another one they don't talk about is for analog, it could be operational amplifiers. And there's all sorts of specialized RF circuits that are in integrated packages. What is the name of a device that combines several semiconductors and other components into a single package?
C.
What type of circuit controls the amount of voltage from a power supply?
A.
A.
Okay. Fuses. They're used to break a connection to prevent current overload. In this circuit, the fuse shown as F1 is going to hopefully prevent resistor R1 from burning up if the supply voltage became too high. And it would also help protect the supply power supply over there by stopping current flow and possibly preventing a fire. I think they get into the fire thing on the general in the question. What electrical component is used to protect other circuit components from current overloads?
I'm going to guess A because I haven't heard of the other two.
Well, we talked about Varactor, but not in detail. Varactor is a special diode that's used as a variable capacitor. And a thyratron is a high power vacuum tube that's, I don't know that much about it. It's not a klystron. Maybe Vyra knows what a thyratron is.
Thought that's one of those Transformers characters on the movie Cybertron. Yeah. Megatron, Cybertron.
Okay. Anyway, correct answer is a fuse.
Yeah, the thyroid problems.
Shielded cables. They're used to prevent coupling of unwanted signals as well as radiation of signals. So it keeps the electrostatic field within that outer shield. Similar to a coaxial cable, except it's not, because they're not coaxial in this case. If there was just one and it was centered and physically constrained to be in the center, so it was equal distance to the shield, it would be a coaxial cable. And normally you connect the shield at least on one end to a ground to act as that Faraday shield. Which of the following is a reason to use shielded wire?
C.
Yeah.
Okay. You guys did really good. You'd pass the test so far.
If we could stay away.
Almost guaranteed to get 9 questions right.
All right. Well,
Any questions?
How many total questions are on the test?
35.
35.
Yeah. So we went through 9 of them. So what we went through the last couple hours, you'll get 9 of those questions that we went through.
Have you ever seen a corn-o-meter?
No.
Really? You should stay up a little bit later.
Well, I do, but I don't watch the same thing you do.
Oh.
What did he say it was?
TV show
A cornometer?
Yeah, it shows B-rated, you know, sci-fi and horror movies.
Yeah.
The guy tell, you know,
What'd you say, pornometer?
porn.
Pornometer.
And the host tells corny jokes about the movie.
Oh,
you know, after
okay.
breaks.
Okay.
So he's got a cornometer that's full tilt.
Ah,
Yeah.
kind of like what Elvira used to do on the mystery movies
Yeah, yeah,
with the, yeah. Okay. Any other questions?
Oh,
The main thing for the test is just go through the practice exams. It's to some people, what we went through today is some of the hardest stuff. To other people, what we're going to do, probably the last session, is the hardest stuff with rules and regulations and some operating procedures. Because those are just legislative things and sometimes they don't make sense. It's just stuff you have to memorize and remember. The band plans are another area where you just kind of have to remember it, what frequencies you're allowed to operate in and what modes. And there's some handouts I have for the people that are here. I assume I'll be seeing you guys in person again sometime. Okay.
Not next week, but the following weekend, you'll see me in person.
Okay. Remind me to give you the band plan stuff. Some nice free material from the ARRL.
Okay.
Okay. No more questions?
Just after we're,
Do you have any trouble with anything?
The conversions a little bit, but I think I just have to brush up on my math.
Yeah, a lot of people have trouble with those. You just have to practice them and get familiar with what micro and nano and pico and all that means.
Yeah, if I could associate them with the correlating power, I could just move the decimals and I'll be fine.
Okay. Remember, when you take the test, you can write anything you want on the back of the answer sheet. So any of that stuff you might have trouble remembering, just write it down as soon as you can. Do your little pie charts and other conversions. You're only likely to get one question about decibels, and it'll be a simple one, you know, like whether it's 3 dB or 10 dB. And we only went through what, 3 or 4 anyway. So you might get one of those. Okay, I'm going to stop the recording.